You're standing outside tonight, staring up. The sky is clear. You can count maybe a dozen stars, maybe 100 if your eyes adjust and you get away from the city lights. It feels vast. It feels endless. Now hold that feeling, because I need you to understand something before we go any further. Every single star you can see from Earth, every one, is inside our galaxy, the Milky Way. One galaxy. And our galaxy is not the universe. It's not even close. The Milky Way contains somewhere between 100 and 400 billion stars. That number alone should stop you cold. But here's what actually matters. Astronomers estimate the observable universe contains at least 2 trillion galaxies. Not stars, galaxies, each one harboring hundreds of billions of stars of its own. So the question isn't just how big the universe is. The question is, what does it mean to live inside something that large, and to have no idea it existed until 100 years ago? Let's start with numbers we can actually measure, because the brain needs a foothold before it can climb. The Milky Way is roughly 100,000 light-years across. A single light-year is the distance light travels in 1 year, about 5.88 trillion miles. So the Milky Way spans approximately 588 quadrillion miles from one edge to the other. That sounds incomprehensible. It should. But stay with me. The observable universe, the portion we can actually detect from Earth, is 93 billion light-years in diameter. That means the universe is roughly 930,000 times wider than our galaxy. Not twice as big, not 10 times bigger, 930,000 times. Here's the comparison that actually lands. If the Milky Way were shrunk down to the size of a single US quarter, the observable universe would be roughly the size of the entire North American continent. We are that coin. We live on that coin. And we spent most of human history believing the coin was everything there was. Here's the key. We are not guessing at these numbers. In 1929, astronomer Edwin Hubble, working at the Mount Wilson Observatory in the San Gabriel Mountains of California, confirmed something that rewrote human history. The faint smudges that earlier astronomers had called nebulae, clouds of dust inside the Milky Way, they assumed, were not clouds at all. They were entire separate galaxies, millions of light-years away, each containing billions of stars. In a single observation, the known size of the universe expanded by a factor of millions. Everything humans had assumed about the cosmos before that moment was wrong. Then, in 1995, astronomers pointed the Hubble Space Telescope at a tiny, apparently empty patch of sky, a region no bigger than a grain of sand held at arm's length from your eye. They left the shutter open for 10 consecutive days. 10 days of accumulating light from the darkest, emptiest-looking slice of the sky they could find. What came back became known as the Hubble Deep Field. That single image contained approximately 3,000 galaxies, in a patch of sky that appeared, to the naked eye, to be completely and utterly empty. They did it again in 2004, the Hubble Ultra Deep Field, and found 10,000 galaxies in a similar-sized patch. Then, in 2012, the Hubble Extreme Deep Field captured roughly 5,500 galaxies in a slice of sky representing 1/32 millionth of the total celestial sphere. Extrapolate that fraction across the entire sky. That's how astronomers arrived at 2 trillion galaxies. 2 trillion galaxies, most of them unreachable. Many of them already moving away from us faster than light can follow. Let's walk through the actual scale, layer by layer, because your brain is going to resist this. That resistance is worth paying attention to. Start here, at home. Our solar system, the Sun, Earth, all 8 planets, and everything orbiting them, is about 287 billion kilometers across at its widest point. That's from the Sun to the far edge of the Oort cloud, the shell of icy objects surrounding us. The Milky Way contains at least 100 billion solar systems. They're arranged in a flat spiral, rotating slowly around a supermassive black hole at the center called Sagittarius A, which has the mass of 4 million suns. Our own sun sits about 26,000 light-years from that center. We're in the outer suburbs of our own galaxy. Now zoom out. The Milky Way belongs to a cluster of about 50 galaxies called the Local Group, which spans roughly 10 million light-years. Our nearest large neighbor is the Andromeda Galaxy, sitting 2.537 million light-years away. Here's the part that stops people. Andromeda is on a direct collision course with us. In approximately 4.5 billion years, the two galaxies will merge into one. By cosmic standards, they're already practically in each other's arms. Now zoom out again. The local group is just a small corner of the Virgo supercluster, a gravitationally connected collection of more than 100 galaxy groups spanning 520 million light-years. And the Virgo supercluster itself is one tendril of an even larger cosmic web called Laniakea, a vast interconnected structure that stretches 520 million light-years and contains the mass of 100 quadrillion suns. Here's the part that gets me. Laniakea is not the universe. It's not even a significant fraction of the universe. It's a neighborhood. And the universe contains millions of structures just like it, stretching in every direction, further than we will ever be able to observe. Now, some of you are thinking, this is all based on what we can observe. What about the rest? Fair question. And the answer changes everything. In 1998, two independent teams of astronomers, led by Saul Perlmutter at Lawrence Berkeley National Laboratory and Brian Schmidt at the Australian National University, discovered something nobody predicted. They were studying distant supernovae, exploding stars so bright they can be seen across billions of light-years, and they expected to find that the expansion of the universe was slowing down. Gravity pulling everything back together, like a ball thrown into the air, eventually falling. Instead, they found the opposite. The universe's expansion is accelerating, getting faster every second. Something is pushing everything apart, and that something, whatever it is, has been named dark energy. We don't know what it is. We just know it's winning. That discovery won the Nobel Prize in Physics in 2011. And what it means is staggering. Galaxies on the far edge of the observable universe are already moving away from us faster than light, not violating physics. Space itself is stretching between us and them. But the consequence is that those galaxies are permanently beyond any possible reach. Not just hard to get to, unreachable by any technology, under any physics, forever. The observable universe, our 93 billion light-year bubble, is the ceiling. Beyond it, more universe exists. The mathematics of inflation suggest it could be infinite. Infinite. And here's where the cascade begins. If the universe is infinite, then by pure mathematics, every possible arrangement of matter that can exist eventually does exist somewhere. Not as philosophy, as a direct consequence of infinite space and finite particle configurations. Somewhere incomprehensibly far away, every possible version of reality plays out. More space means more dying stars. More dying stars scatter heavy elements, carbon, iron, oxygen, into the gas clouds between galaxies. Those elements collapse into new stars, form planets with complex geology, and seed the chemistry that, on at least one world we know of, eventually built something that could ask questions about all of this. Statistically, given what we know about how common planets are, how universal chemistry is, and how relentlessly life has filled every niche it can find on Earth, we are almost certainly not alone in this universe. We just cannot reach them, and they cannot reach us. The universe is vast enough that even civilizations that have existed for 1,000,000 years longer than we have may never close the gap. So let's come back to you, standing outside tonight, looking up. Every star you can see is a sun, most of them larger and older than ours, many surrounded by their own planets, all of them inside one galaxy, one of 2 trillion. You are made of atoms forged in the cores of stars that exploded billions of years before Earth existed. Those atoms drifted across interstellar space, collapsed into a new solar system, built a small rocky planet in a habitable zone, and through 4 billion years of chemistry and biology, arranged themselves into something that can stand outside on a clear night and look back at where they came from. That specific act, looking up and wondering, is, as far as we can tell, one of the rarest things in the observable universe. We are cosmically, incomprehensibly small. And somehow, against all odds, we are the part of the universe that got curious about the rest of it.